Okay, so we have our completed skeleton with its orientations and its mirrored attributes and mirrored joints. And we have our mesh. So let's dive into skin weighting. So let's start with that biharmonic skin weighting method that we explored when we were setting up our tube in the first week. We will put down a bone capture lines to grab our joints. There we go. And we will grab our tet embed node to create that spider web mesh. We'll let it think while it does so. And we'll input our bone capture lines as the additional points and curves. Then we'll put down our biharmonic capture. And we'll put in our mesh and our tet embed. And we'll let it think as it does so, applying those skin weights from our spiderweb mesh, our tet embed mesh, to our base mesh. And then we can start to view this when we put down a bone deform, and we start to plug in our skeletons into our bone deform. Now when we edit the deform chain, we can see the base skinning that comes through. And it's not bad at all. In fact, it's quite good with things like the legs. We can see that that's actually quite a good deformation in the knee already based on where our joint placement is. I'm pretty happy with that and probably won't need to edit things very much from there. Even our hip isn't so bad. As we can see, it's grabbing a bit of our spine in there, or our body, but even then it's not terrible. It deforms quite well. Our ankle is not bad either. The ball of our foot, we can see it does quite a good job with just a base skinning already. Our fingers might have a little bit of problems, and I'll explore why. You can see that we're dragging the fingers there a bit, and let's explore why. If we go and view our tet embed mesh, we can see that the mesh it makes is let's actually view our base mesh, and then we'll view our tet embed on a wireframe. We can see that that tet embed has expanded out beyond the reach of our mesh, just so it can make sure that it applies our skin weights to our mesh properly. And we can see that it kind of spans this shoulder, or sorry, the armpit as well. And we can see that when we edit our arm here. If we were to drag that up, we could see we get some of that armpit area. But even then, it's actually not terrible, and I'm pretty happy with how that shoulder is solved with our rotation points. Granted, it's got a bit more of the back and stuff than we probably want, but it keeps our deltoids in shape nicely. So not much to complain about just out of the box. Now this could definitely use some work. Grabs probably too much of our neck and too much of the side of our body. But that's what we can start to paint stuff with. Our paint capture paint layer will help us with that. But let's explore further this tet embed that I was talking about and our fingers. So we can see that this mesh has some definition between our fingers, but especially not between our pinky and our ring finger. There's a melding of our mesh here. So if we move our pinky here, we can see we move a lot of the ring finger, or the pinky is skinned to the ring finger. We can kind of adjust this out of the box package by adjusting our tet embed in large offset amount. And we can also adjust our max tet scale and our min triangle scale. But first let's just adjust the offset so it's less big. So it's not as big, and we'll let it recreate the mesh, and it'll have to redo its biharmonic skinning on our mesh there. We could see it progressing bottom left. So we can see once we adjust the enlarge offset, we can see that the tet embed mesh adjusts to be smaller based on our input here. Now, just now in between where you saw me edit the value and where we are cut to now, Houdini crashed on me quite a number of times, and it was because my theory anyhow is that on the fingers in certain part of the meshes, I set the enlarge offset to be, and our triangle count to be small enough that our the tet embed mesh didn't quite construct around all the fingers completely, and I can try and show that with a separate tet embed over here. So let's try and just do a 2, which is what we were trying for, and we can view that and it'll cook. Now the separate tet embed has been cooked, and we'll put it on template mode instead. We can see that that mesh doesn't quite build out to all the way around the fingers quite well. And when I was hooking up the offset enlarge 2 into our bone capture, the bone capture biharmonic was stalling out and crashing Houdini repeatedly. So just know when you're approaching skin capturing with the biharmonics on Houdini 19.0.589 that there may be some heavy computation when using the tet embed and the biharmonic capture, and to just be careful, save often. Skinning is always skinning and mesh capture is always a finicky thing with any DCC that I've worked with, from Maya to Houdini. But that's how we can get a finer capture mesh. And now if we adjust our fingers back from where we were before, we can see that we don't drag as much of that mesh along our way. Now, from what I recall, the pinky still had some fused mesh, so we might still drag some of the pinky along. But even then, it's better than where it was before out of the box. So from here, of course, we can put down a capture layer paint, and we can start to paint just like we were before with that attribute delete if we don't want to see our textures in here. There we go, and we can just skip over that when we're done painting things. So we can either come in here and start painting things, posing with our rig pose here so we can see how our mesh deforms, and trying to paint as such, just adding to mesh. As we can see here though, we might start to encounter an issue if we're painting by hand. These plated armors and our wires and our mesh underneath are all separate. I mean, it's all one combined mesh file, but they're all their own surfaces, their own pieces of geometry that can collide with one another here, as we can see there. So what I would recommend doing, and what I did to get a better skin result, is similar to how we skinned a whole spring in the first week using a cone. I would make a simplified mesh, which I did here. I will pull it up here. You can make a simplified mesh that we can use for skinning purposes. This simplified mesh, you can create it however you wish. We might provide it in the course, we might not, but create a simple mesh that you can skin instead and put through the tet embed process, and then do an attribute copy to copy your skin weights over to your main mesh, and you'll have much better results moving forward between trying to paint on all these layers of mesh that we have here. That's how I would recommend going about skinning this particular character, or any other detailed characters with layered meshes like this. We kind of just want to paint one mesh, and of course after we do that paint layer, just like in the first week, we can still put down a new paint layer for our real mesh and start to smooth out the kinks. So let me show you what that would look like. We can take our cyborg face false mesh here, and we probably will need a new capture layer since we take in some joints, but we can put it into, I'm going to save this real quick, save early and often, and put it into our material, which we don't actually need to put it into our material, we can just put it into our tet embed and our bone capture. And hopefully now if we view our bone deform, awesome. It took a lot easier because it's the less detailed mesh, and we can start to paint this and attribute copy over when we're ready to. Now the reason I had to create a new capture layer paint is because it stores the mesh data of our objects. So if we were to put in a new mesh, we'd get an error. It would say the meshes don't match the skin weights, or the painting data that we put onto our mesh doesn't match the data that we've put in, because there's a different point number system between our meshes, because there's simply more points and a different construction to how they are. So we can paint our base mesh there like that, and we have our real mesh down here. We can then put down an attribute copy like such. Geometry to copy attributes to is our mesh. We're copying from our painted mesh, and we want to copy on points, and attribute transfer is what we want to do, not an attribute copy. There we go. And we're going to transfer points, and it's going to be our bone capture information here. And if we put that into our bone capture instead, and we start to view it, we can now see our mesh based on that attribute transfer. And we can edit some values in here. Like our conditioned values here. We can try and smooth things out. Sample count we can increase, and it'll affect, try and make things smoother, as we can see here. Of course, we're also providing like a kind of a blurred line between things, so we can see we're giving more value there than maybe we want to. Kernel radius you can adjust, and blend width you can adjust as well. And just seeing how these things affect one another. The area that I found to be decent was 5 and 10 for my particular transfer here. And then we can put down another capture layer, paint, there it is, right here. And we can now start to paint, or really just smooth out our transfer here. And it produces a lot less worry in overlapping meshes, since our meshes are defaultly following along with each other, and we're just kind of smoothing out stuff. Of course, you'll want to adjust your skinning on your base mesh first, so if we want the delts to follow a lot more, we want to adjust that, and then we can come back down here and we can see that effect in place. So this is how I would skin a character this complicated in mesh. Go through and finish skinning your character, and we will then talk about copying the skin weights over to our right side. So just go through and skin your left side of your character, and we'll talk about mirroring the skin weights like we mirrored our joints. Welcome back. I've gone ahead and completed the skin weighting on my mesh, and we can see here that I've gone through a pipeline where I took that initial mesh, that kind of low poly mesh. I skin weighted it initially, and then I saw when I was transferring our skin weights over that there needed to be a bit more definition in the elbow. So I just made some poly splits here. We can see those edits in the elbow, and I made a new capture weight. Since now that there's a new topology, we need a new capture weight, and I applied that to our attribute transfer. And any weights that I had adjusted down here were still kept when I applied the second layer of capture layer data. And now we have this decent capture system here, where we can see the shoulder is nice intact. I didn't spend a whole lot of time on this since the demo has already been made and we use different assets for that. This is for purely instructional purposes, but we can see that I mainly just used this final layer to smooth out the transfer attributes. So I hope this helps you solve some skin weight problems you may have been running into if you were working on skin weighting in between this video and the last video. Let's talk now about transferring or mirroring our skin weight data. Our main node that we're going to use here is a capture mirror. And we'll notice we have a few things that we need to do. We need a from and a to. We also need this here in between our bone deform. We're applying it to our mesh path of things, and after our bone deform is just a deformed geometry that doesn't have many of our attributes. So we need a capture mirror here, and we can select bones in our from. Unfortunately, there is not an easy way for us to select multiple bones at a time. The input for our from and our to groups are not the same as our inputs for most of KineFX. This is an old node used prior to KineFX that came from the bone hierarchy of things. So currently in this version of Houdini, we need to go through and select all of our left joints individually. Very tedious. And our group, you might think, oh, we can select our group here. But no, the group is actually referring to points on our mesh that are our destination or our, we can say, source points as well. So our group just ensures that if we want to grab a specific section of our mesh that we are grabbing from or pasting to, that's how we can determine that group of things. Normally it does a decent job of knowing if you're transferring from a left side to the right side and knows to grab those things. But an easy way to grab only the left side of the points is the same way we did earlier with our bones when we mirrored them. Taking a group node here and grouping things by a bounding box and simply moving the bounding box logically to just the side and make sure it captures points. And we can capture all the points that we need to, 0.51, and just expand this up like so. And we have our needed points. We have quite a big bounding box. So that's kind of the easiest way we can grab all the points. We notice we don't grab the center chain of things, which is not necessarily a bad thing. And I set that just because it's 0.05 or 0.51. If we have it at exactly 0.5, we'll kind of half grab some center ones, half not. So I like to just not grab center points for clarity. So if you want to use that method to group your left side, and we can determine it as the source, then you can do so. So you'll need to go through and select all of the left joints, and then in the to section you'll need to select all of the right joints as well. So I'm going to do that real quick. So now that I have all my left joints selected and our right joints are a mirror, we can just do a simple Control C, and if we need to, we can pull up something like a notepad and just paste those all in there and do a we need a smarter tool. Something like Notepad++ can help us here. Just paste all of those things. Do a Control R, or do a search and replace rather. Control F. We're going to find. We're going to do a place. Find what? Just an L underscore and replace with R underscore, and we will replace all. And now we have all of our R names. We can just Control C that, and we'll put it in here. Control V. And now we have all of our right bones as well. Taking a look at our capture mirror back again, we want to make sure we're mirroring in the negative X, because right now we're mirroring from right side to left side, and we want to do the opposite. So we'll take a negative there, and we can see we got a change in color already. We can undo that just to see that change, or rather we got a change in this axis. And if we start to deform our mesh, hopefully we'll see a change in our mesh to be symmetrical. We could test this just with our shoulders here. So it's not quite symmetrical. Something went wrong a bit. Some things worked well, as we can see the shoulder here kept its shape pretty perfectly, but our center skin weights kind of got a bit messed up here. So anything on our actual sides that we just copied from and to weighted well, but we didn't actually reference any of our center here. I wonder, did I? So we didn't reference any of our center bones here. So we'll put down another capture mirror. I'm going to do it before our sides, and we'll do a mirror of the middle. And in this mirror, we want to grab our middle joints instead. So we could still determine our left side as our source, and we still want to do a -1 direction. This time though, we can grab all of our other joints that we needed, or that we didn't have in our other ones. So our spine and our hip. So we're going to continue grabbing all of our spine joints, our mid joints, like our head and our neck, and just getting all of the middle points that we didn't already mirror with our left and right sides of things. I think that's everything, and we need to have a from group and a to group, so we're just going to copy that over. And now we can check and see what our results are. We'll check with that same shoulder rotation, and we'll see how things go. So things are still having a little bit of trouble. So we'll go through and look. Maybe it's our source group. We'll see if just getting rid of that and letting it do its thing changes anything. Not quite. I will investigate this further and be right back. Okay, changing our mirror from being a source, use group as a source, to destination, and getting rid of our mirroring group, our point group, seems to have allowed it to compute properly. Like I said, I'm not sure why certain aspects of this node do the things it does. It's an old node that's definitely still being worked on to work with kinefx properly. It was set up for the bone hierarchy of things. In fact, so were the biharmonic nodes, and they were kind of stripped of their old use and applied to being able to be used in kinefx. So there's still probably some hiccups here and there that we'll run into. But we can see now that our mirror is working perfectly. We have it completely mirrored. Our character is doing exactly the same thing on either side as we edit this mesh. And we didn't have to work on the right side at all to skin weight. Perfect. So now our skinning is complete, and we'll move to our final section of this week, which is compiling all of this data down into a simple HDA so we can hand it off to other team members if maybe we're not responsible or you aren't responsible in your pipeline for creating the rigging aspects, if maybe you're just the skin waiter or whatever. We are going to compile it and condense it down into a single HDA so that we can also not only hand it off to people, but it's more efficient to be used later in our pipeline, and we don't have all of this data backing us up. If you've opened your scene, if you've maybe saved and come back to watch these videos, you may have noticed that each time you open this scene, it takes a minute to compute its embed method. So we are going to export out our skin weight data and our skeleton and build a new HDA that's much more streamlined.